All right, hello. We're going to be doing this particular lecture on components of the atmosphere. This is really important because what we have to figure out is that interaction between the atmosphere and the ocean, figure out how those chemicals that are in the atmosphere actually get into the ocean. So the first thing that we need to take a look at here are these components of the atmosphere. So the first thing we need to look at with the atmosphere is the air. And the air is just a mixture of the gases that are surrounding us. So when you're hot and you're waving at yourself and you feel all that air hitting you in the face, what you're actually feeling are gases, those molecules hitting your skin. What are those particular molecules? Here's our list of these particular molecules. Nitrogen, 78%, a huge amount of those particular molecules that are hitting you in the face made up of this nitrogen. Oxygen, 21%. Another huge amount, which is important because that's what organisms like ourselves are using to create a little bit extra ATP in our cells. And then we have a gas that many of you are probably not as familiar with. That's the gas argon. It's one of those noble gases on the far right-hand side of the periodic table. Makes up 1%. Carbon dioxide, very low amount, 0.03%. So when we're talking about this adding of carbon dioxide into the atmosphere, well, we just have to add a very little amount, which will affect this percentage greatly. That's why scientists are so worried about that CO2 level that we're adding into the atmosphere. All of the other gases combined, 0.01%. Now you'll notice if you really add all of these up, we're a little bit over that 100%. But remember, these percentages up here, we're rounding up. So it's not actually 21%, it's a little bit less. Not actually 78%, it's a little bit less. And that's where we get all of these particular percentage to make up those particular components of the atmosphere. Now the important thing to remember about all of these things is that most of them are a part only of the lowest layer of the atmosphere, the part that's close to Earth. Now, in order to understand how we look at these, put this diagram up here for you so you can take a look at these layers of the atmosphere. It's really important to know these layers of the atmosphere. And you might even go as far as to say it is essential for you to know these. But you should know the troposphere. That's the lowest one. That's the most important one because this is the one that interacts with the ocean and with us. We have the stratosphere. That's the next layer moving up away from the Earth. The mesosphere, I remember mesosphere is it's in the middle, so we use that M. And then the one where all the heat escapes out into space, that's our thermosphere. So troposphere, mesosphere, stratosphere, and thermosphere. Now, of all of these gases, I said that they're only a part of this lower layer. There's very few of these particular molecules extending out. And the reason that most of them are down here is because of the gravitational pull of the Earth. That is extraordinarily important. Most of those gases down here, because of Earth's gravity pulling them down and holding them close to the Earth. So, how do these gases get into the atmosphere? We're going to abbreviate atmosphere just as ATM right there, a little bit easier to write down. So how they get in, well, the movement of many of these molecules is through a process we call biogeochemical cycles. Bio meaning life, geo meaning Earth, and chemical is, well, chemicals. So these are moving through these biogeochemical cycles. And you learned a little bit about these biogeochemical cycles way back in biology. The definition for a biogeochemical cycle I have right here. It's the continuous flow of elements and compounds between organisms and the Earth. Continuous flow, so we're cycling through these organisms and the Earth. There's a few that are more important than others. So the important ones that we're going to need to know, the carbon cycle, water cycle, nitrogen cycle, and even the oxygen cycle. You don't need to write these down just yet because we're going to cover them here in just a moment. So the first one is the carbon cycle. You should be probably very familiar with the carbon cycle. Carbon is a fundamental element of life. It's the basis for all chemical energy. That is glucose. That's the important one to remember, that glucose. And for building tissues in all organisms. Now, how do we get this carbon from the atmosphere into organisms? Through that process of photosynthesis. So to transform that carbon dioxide into compounds such as glucose. And once we have it transformed into that glucose, organisms are going to be able to use it. Now, the CO2 that is in the atmosphere is going to interact as well with the ocean. And this is where this marine biology section kind of comes into play. It's dissolved in the water, and it's dissolved in tremendous amounts in the ocean. And the ocean is what we call a carbon sink. That is, the carbon actually sinks into the ocean, and it stays there. The fancy word for that is sequestering, and we'll talk about that a little bit more in class. How that carbon dioxide dissolves into the ocean? Literally by mixing with the water, but there's other ways it can get in. Through absorption by plankton, those particular organisms floating on the surface that are doing photosynthesis, just like plants, are going to absorb that CO2. When those organisms die, they sink down, carrying that CO2 with them into the bottom of the ocean. And that's where those plankton go when they die and sink down. Now, the CO2 is also going to interact with the water when it's dissolved in the water, not just stay as CO2, but it's actually going to interact with that water, and it's going to form H2CO3, called carbonic acid. This is going to alter the pH of the ocean. We're adding an acid in there now, so the pH of the ocean is going to change a little bit. Not good. The water cycle, the next one. Process of that water circulation from clouds up here in the atmosphere, then down to land, to the ocean, and back again. A couple terms that you should be familiar with, and I'm pretty sure that you are with most of these. Precipitation. This is where this water is coming back down to the earth from the sun. From the atmosphere as liquid or solid. Condensation. H2O is returning to liquid. So we have this condensation and precipitation process. The water has to condense before it can fall back down. Then we have evaporation, where the H2O is turning into a gas from the liquid. This water, once it's in the atmosphere, is transported around the earth. Transported from land, where it can evaporate from the land back to the ocean. Goes from the ocean, where it evaporates, to the land. Goes from the ocean to the ocean, and land to land. Now, there is a freshwater return to the ocean. When that water falls down onto the land, it flows back to the ocean in the form of rivers, streams, creeks, etc. So this is part of this water cycle. How are we moving this water all around the earth? And you can see in the picture here, there's a lot of areas going all over the place. We've got the ocean out here, we've got evaporation, condensation, precipitation falling down, we've got this groundwater, we have rainfall here. So there's a tremendous amount of this movement of water. And as this water is moving, all of these things here are affecting things like the salinity. Adding more fresh water is going to change the salinity. It affects the pH. It's going to make it a little bit more towards that neutral area. And it affects the density of the water in the ocean. As we're bringing more fresh water in, it's less dense. So we have a whole bunch of this precipitation, condensation, and evaporation effects on the ocean. Next up, we have the nitrogen cycle. This is extraordinarily complex. When you look at this one, there's a lot of stuff going on over here. You see stuff happening on land, you see stuff happening in the water, stuff happening in the atmosphere, but we're going to simplify it for you. The most important part for you to know about the nitrogen cycle, and I'm telling you this is an essential skill. Nitrogen is in tremendous amounts in the atmosphere. Remember, it's 78% of all of these molecules that are around us right now. Nitrogen is required to make proteins. We need the N to make proteins, nucleic acids, to make chlorophyll specifically. So we need that. So now the issue is, how do we get it into our bodies? Most organisms cannot use this atmospheric nitrogen. We can't use it. When we breathe in, we only talk about us breathing in oxygen, not nitrogen. So that's really, really, really important to remember, that organisms cannot just take in this nitrogen that's in huge abundance in the atmosphere. So in order to get it in, think of it as the nitrogen is broken. And it must be fixed so that we can get it into our bodies. So we do this process called nitrogen fixation, and that's the most important thing for you to remember. Some bacteria are able to absorb this nitrogen gas, N2, and then they're able to transform it into a usable form. Make sure you get this down. It can't overstate how important that one is. The issue is that most of these bacteria exist on land, not in the ocean. So organisms that are living in the ocean are depending on these land-based bacteria mostly to get the correct form of that nitrogen. So where water is moving this correct form of nitrogen from land into the ocean, that's where that usable nitrogen is. So this usable nitrogen gets into the ocean where runoff, where we have rivers and streams, etc. And that's where we find most of the life. If you think about the ocean, when you go to the ocean, there's a lot of living organisms near the shore, on the shore, close to where runoff is occurring. Out of the middle of the ocean, there's very, very few organisms that are living out in the middle of the ocean because there's not very much nitrogen there. We have the oxygen cycle. For the oxygen cycle, a few things here. Let me run through this stuff and then we'll get to allow you to write this information down. To survive, organisms need what we call dissolved oxygen, DO, in the water. So we have to have that oxygen dissolve into the water. How does it get there? Through diffusion with the atmosphere or through organisms that are performing photosynthesis. Part of that photosynthesis process, they absorb that CO2, take in water, which is in abundance in the ocean, and they're able to then create oxygen and sugar. We get this through diffusion by having winds and currents mix that water. And as that happens, it's going to increase the surface area, allow for more absorption. So winds and waves, very important for this diffusion of oxygen into the water. Now, one part that's very, very important for us to understand about this, as the temperature increases and as the salinity or saltiness of the water increases, how well oxygen dissolves or the solubility is going to decrease. So in those warmer areas of the world where the temperature of the water is warm and where there's more evaporation, so there's more salt left in the water, there's not as much oxygen in the water. So when you go to the tropics, there's a reason that the water is so clear, because not as many organisms are able to survive because there's not as much oxygen as there is, say, off the coast of San Francisco, where the water is very murky. There's a lot of stuff in the water, organisms and nutrients. Temperature is much lower, salinity is lower, and so there's more oxygen available in the water. As we get more and more organisms in the water, there are organisms that are going to consume the dissolved oxygen. That's why we have this DO here, and it's going to reduce those levels of dissolved oxygen. We get areas where there's more nutrients that are being brought into the water. That's going to increase the number of organisms, which is going to deplete or decrease those dissolved oxygen levels. On top of all of that, if we get more organisms and more nutrients, those organisms are going to die. They're going to start to decompose. There's going to be more bacteria to decompose them, and that's going to decrease those dissolved oxygen levels. So there's a very specific balance of oxygen that is able to enter into the water through diffusion or photosynthesis with the number of organisms that are there. And what we see here is there are certain areas where we're going to have a lot of oxygen. Up here at the surface, lots of oxygen. Down here near the bottom areas, not as much oxygen. We get into the deep ocean, not as many organisms down there, so there is a lot of oxygen down in the deep ocean. So we have these particular areas of high oxygen content near the surface. Down in the middle areas, low oxygen content, we don't see as many organisms living down in that particular area. And this is all that we have for the lecture today. It was a quick one, and hopefully we'll be able to do a little work with this information and get a very good foundation for what we're learning here in the components of the atmosphere.